Hello, my name is Keshwani. There's K-E-S-H-W-A-N-I, Keshwani. We are here because we want to prepare for GRE. We have been solving GRE math problems out of this book here, the official guide to the revised GRE, the second edition. If you do not own this book already, purchase one immediately. You're going to need it. The problem that we are about to solve is the one that you will find on page number 244. Please turn to it. Page number 244, and today's our lesson number 350. This problem that you see there on page number 244, problem number 6, is the exact same problem that appeared in the first edition of the revised GRE. We have already solved every single problem from this book. If you're interested in watching the original solution to the problem, you will find the original solution on day number 142, where we did the same problem at a much slower pace. Here's what's going on. We have a quadratic equation here. As with any quadratic equation, we have as with any quadratic equation, when we have to solve for its roots, the solution of the equation, we have two choices. We can either look for the factors, we can either utilize the factorization method, a method called factorization, or we can simply use the quadratic equations. Let's first see if we can find the factors, shall we? How do we look for factors? We have done this many a times. Here are the list of videos that you can watch, which will help you learn the method of factorization. We should add one more video to this list, which is day number 349. We just did one yesterday, day number 349. 338, 349, 312 through 315, 144, 142, 124, 129, and finally 99 through 103. All of those videos deal with the concept of factorization. We're looking for two numbers. We're looking for two integers such that their product has to equal positive 1 times negative 1. Where is this positive 1 times negative 1 coming from? This positive 1 is coming from the fact that this guy has a coefficient of positive 1. And this negative is coming from this negative 1. So their product has to be the product of these two things, the coefficient of x squared and the constant. So positive 1 times negative 1 is negative 1, and their sum has to be this middle term, which is negative 1x right here. Can you think of two such numbers? Can you think of two such integers? Now, why do we emphasize integers? Because of course there do exist two such numbers which will satisfy these conditions, but they're not going to be whole numbers. Why do we say that there does exist? But there has to be a solution. There has to be a solution to this problem, but it's not going to be nice round whole numbers. Do you understand? What you will find is that no matter how hard you try, you're not going to find two numbers such that when we multiply them we get a negative 1, and when we add them we get a negative 1 also. Positive 1 times negative 1 is going to give us negative 1, but when we add positive 1 and negative 1 we get 0. No such numbers exist. No such integers exist. No such integers exist. Our only salvation is to use the quadratic formula. We must use here quadratic formula. There is no other choice. So let's use quadratic formula, shall we? We can factorize it. And quadratic formula is something that you have to know by heart for the exam. The exam givers, the people who give you the GRE exam, they take it for granted that there are certain concepts of mathematics that you will know, that you will have at your fingertips, and one of those concepts that they expect you to know is quadratic formula. It did not exist in the old GRE, but now we are dealing with the revised GRE, and the revised GRE does have a lot of things that did not appear before. One of them being the prerequisite of the knowledge of quadratic formula. And this is how the quadratic formula goes. X is equal to minus b plus minus b squared minus 4ac over 2a. And what are these a, b, and c? Our a is this guy. Our b is this guy, negative 1. And our c is negative 1. So our a is positive 1, our b is negative 1, our c is negative 1 as well. So let's do it here. Minus b is negative 1. So minus b, which is negative 1, plus or minus b squared. B is negative 1. So it's negative 1 squared minus 4 times A, which is positive 1, times C, which is negative 1. You have to take your time, you have to slow down, because otherwise you're going to muck it up, you understand? You're going to muck it up with an M, not an F. Over 2 times A, which is positive 1. So let's see what it boils down to, shall we? Let's see what it boils down to. Negative times negative 1 is just 1, plus or minus. Negative 1 squared is going to be 1. Negative 4 times positive 1 times a negative 1. Positive 1 times negative 1 is 1. Positive 1 times negative 1 is negative 1. And negative 1 times a negative 4 is going to be positive 4. Over 2 times 1, which is 2. So it boils down to 1 plus or minus the root of 5 over 2. 1 plus or minus the root of 5 over 2. That's it. Those are the two roots. Those are the two roots. Now listen very carefully. As far as this question is concerned, we are done. We have found a solution. These are the answers. These are the exact same answers that you're going to find in the back of the book. Well, not quite the back of the book, but if you turn to page number 246, they give you the answers to this problem, and this is exactly how they give you the answers to the problem. 1 plus root 5 over 2, 1 plus root 5 over 2, and 1 minus root 5 over 2. Those are the two roots. As far as the exam is concerned, as far as this question is concerned, we are done. If you want to stop the video right now, it's okay. I'm going to continue here for learning purposes. We're going to do a little bit more with it. We're going to play with it a little bit. You will get something out of it if you're willing to put in the time, if you're patient. So let's see what else we can do with it. Okay, stay with me in this story. I need the room. I need a great deal of room. Listen very carefully. You must know, in addition to quadratic formula and in addition to several other things that appear on the exam, one of the requirements, well, it's not a requirement, but if you want a decent score, you are expected to know all your squares 1 through 20. So let's list them, shall we? 1 through 10 is not a problem. Almost everybody knows 1 through 10. So let's list 1 through 10. So 1 squared is 1, 2 squared is 4, 9, 16, 25, 36, 49, 7 squared, 8 squared is 64, 81, and 100. This is not a problem. This is not a big deal. Almost everybody knows this thing. But you must also know your squares 11 through 20. Stay with me in the story. As I told you before, you will get something out of it. You have to trust me on that. But trust me in the sense that you have to listen to me once, and then if you feel that you didn't get anything out of it, then next time you don't have to listen to me. I need the room, so we're going to erase all of this thing. Now we're going to do our 11 squares, 11 through 20. So let's do them here. 11 squared is 121. 12 squared is 146. 166. 13. 194. 14 to 25. These are squares of 11 through 15. 11 through 15. 11 squared. 11 squares, 12 squares. Do you see something? Do you see something wrong? Yes, right here, 12 squares. I don't know what the 12th square is. I do not know what 12th square is, but whatever the hell it is, it cannot be 146. I do not know what it is, but it cannot be 146. Why? Because when you multiply 12 by 12, the unit digit must be 4. The unit digit has to be 4. It has to end in a 4. It cannot end in a 6. Similarly, 13 squares, when you multiply 13 times 13, I don't know what 13 square is, but it is not 169. I can tell you that this is wrong. I don't know what the 13 square is, but it cannot be 166. This is how alert you have to be in the exam to catch your mistakes. It cannot be 166. 13 times 13, you will find that it is 169. Anyway, let's not make too much fuss about it. Similarly, 14 times 14, 4 times 4 is 16. It has to end in 6, 196. So that takes care of 13 square, 14 square, 15 squares. That's it. Those 5s are done. Oh, I didn't mean to erase that part. Oh, jeez. Those are done. 16 squared is 256. 17 squared, 18 squared, 19 squared, and 20 squared. 17 square, 18 square, and 19 square, they do not appear very often in the exam. You don't have to worry about them. And if you need to figure them out, you can just do them very quickly. 20 square is very easy because 2 times 2 is 4, and then you stick 2 zeros. 20 times 20 is just 2 times 2 is 4, and then 2 zeros. It's 400. Now here's my question. My question is this. Our answer was x equals to positive 1 plus or minus root 5 over 2. My question is, if you had to approximate this thing very quickly, will you be able to do it? If we had to approximate, well, how would we go about approximating it? Should we find out? Can you tell me, before we worry about root 5, there are 3 roots that you have to know by heart for the exam. The first one is the root of 2. Root of 2. Do you know what the root of 2 is? Well, you don't have to worry about it. If you know your squares, you can figure out root of 2 very quickly, because we just found out that 14 squared, 14 times 14, we just found out is 196. Didn't we just find out? 14 times 14 is 196, is right here. Well, if 14 times 14 is 196, this stands to reason that 1.4 times 1.4 must equal 1.96. But 1.96 is very close to 2. This is 2. Therefore, square root of 2 is approximately 1.4. Strictly speaking, 1.4 is the square root of 1.96. Right here, 14 squared is 196. So if you have to approximate root of 2 in the exam very quickly, 1.4 is good enough. And like I said, you don't have to memorize this thing, it comes straight from here. If you know your 14 squared, you know the root of 2. Let's do root of 3, that's the next one. Root of 3, where would we find root of 3? Well, the root of 3 here, well, let's see what we can do. We need to get some close to 3. Where's 16? 16 is right here. 16 times 16, we know, is 256. 256, which tells us that 1.6 times 1.6 is 2.56. 3 is not that far away. So let's try 17, shall we? This 17 that we left blank, let's try that, shall we? 17 times 17. 7 7s are 49, that's 9, carry 4. 7 1s are 7, plus 4 is 11. And times 1, 17. With 9, 8, and 2. What do you know? What does it tell us? It tells us if 17 times 17 is 289, it tells us that 1.7 times 1.7 must equal 2.89. But 2.89 is very close to 3. Therefore, the square root of 3 is approximately 1.7. You have to know this by heart. And it comes straight from here. 289. Let's put it in here. 289. Actually, I do not know that by heart myself, so I'm not going to put it there. I can't expect you to know something that I don't know myself. I just have to do it out. Let's move on then. The last one that you have to know for the exam is the root of 5. You have to know that by heart. Okay, so listen carefully. Root of 5 has to do with 500. Listen very carefully, okay? I need the room. I'm going to erase all of this thing. We need the room here. We know square of 20 is 400. We know that square of 20 is 400. And you also have to know square of 25 by heart. These are, if I tell you that you have to know by heart, then you have to know it by heart, okay? You have to know square of 25 by heart. If there is a person in the exam, in the middle of the exam, and if that person has to figure out what square of 25 is, and I find out that that person is reaching for the calculator on the screen to figure out what is 25, 5, 25, there's a clear indication, there is a giveaway, there's a clear indication that that person will not get a very good score in the math portion of the GRE. They might get a very good score, a great exceptional score in the English portion, but they will not get a good score on the math part. If the person has to reach for the calculator to figure out what 25 square is, that person is not going to get a good score. There are some things that you have to know. So we know that 25 squared is 625. Listen to me very carefully. We also know that 20 squared is 400. We're looking for 500. Now 500 is somewhere between 400 and 625, which means square root of 5 obviously is between 4 and 5, because square root of 4 is 2 and square root of 4 is 2, and the square root of 2.5, square root of 6.25 is 2.5, and the square root of 4 is 2. We're looking for 5. 5 is between 4 and 6.5. Should we try 2.1? We know it's between 2.0. We know it's between 2 and 2.5. It has to be between 2 and 2.5 because the square of 2.5 is 6.25. The square of 2.5 is 6.25. And the square of 2 is just 4. Therefore, square root of 5 has to be between 2 and 2.5. I'm not going to waste the time doing 2.1 because 2.1 to me looks very close to 2. We are somewhere in the middle between 4 and 5. This is 5. You see, this is almost halfway there. Let's try 2.2, shall we? Let's try 2.2. So we don't have to do 2.2. This is silly. Let's do 22 times 22. 22 times 2 is 44. 44 to 4, carry 4. And 22 times 4, 22 times 2 is 44 again. 44 plus 4 is 48. Oh, what do you know? What do you know? That tells us that 2.2 times 2.2 is 4.84, which is approximately 5. Therefore, the square root of 5 is approximately 2.2. Now we can do our work. Now we can do our work. All of this thing is not necessary. Do you understand? As far as the problem was concerned, we were long ago done. We are just doing it for the fun. So let's do here. So our x is going to be equal to positive 1 plus root 5, which is 2.2, over 2. But square root of 5 is not exactly 2.2, it's approximately 2.2. So we cannot put down equal to it. This has to be replaced with approximately equal to. 1 plus 2.2 is 3.2. 3.2 divided by 2 is 1.6, which means x is approximately equal to 1.6. This is the first answer. X is approximately equal to 1.6. Let's make a note of it here. X is approximately equal to 1.6. Let's do the next one. In the next one, we have a negative part here. It's 1 minus 2.2. 1 minus 2.2 is going to be 1.2. Negative 1.2. 1.2 divided by 2 is going to be 0.6. Negative 0.6. Negative 0.6. That's it. We're done. That's it. The very last thing that we want to do, that we always do, is to verify our answer. Shall we? Let's verify our answer. The equation was x squared minus 1, x squared minus x minus 1 has to equal 0. If we put in 1.6, 1.6 squared minus 1.6 minus 1, how much is 1.6 squared? 1.6 squared comes straight from 16 squared. 16 squared we know is 2.5. 2.56. 2.56 minus 1.6 minus a 1. 1.6 minus a 1 is 2.6, which is approximately 0. So 2.56 minus 2.6 is approximately equal to 0. It's not going to be exact because the root of 5 is not exactly 2.2. It's approximately 2.2. So it works. Let's do the next one. X squared minus x minus 1. And now we try the negative root. negative 0.6 squared minus a negative 6.6 minus 1. What's going to be negative 0.6 squared? Well, 6 squared is 36, so 0.6 times 0.6 is going to be 0.36. And negative times negative becomes positive. So plus 0.36, and this is going to be negative times negative is going to be 0.6 minus 1. And 0.36 plus a 0.6 is going to be 0.96. 0.96 minus the 1 is approximately 0. There you go, you see? It works. It's verified. It's going to get very close to it, but not quite, because of the fact that we are approximating here. Now, why did we do all this thing? Just because it's not in the problem, it does not mean that you should stop. It's one thing to do the problem in the exam, is another thing to get ready for it. When you want to get ready for the exam, when you're doing exercises in the book, it does not hurt to go the extra mile. The more you practice, the more comfortable you will feel with numbers. And your mind will begin to work in a manner that it is suspected to work in the exam at the speed that they expect you to work at. All of this thing, it just shows that you are comfortable with the numbers. That's the important part. You have to be comfortable with numbers. You should not be scared of it, and you shouldn't have to reach for the calculator every few minutes. There is no reason why you should have to reach for the calculator. Did we reach for calculator anywhere here? We did not. I'll see you tomorrow, okay? Bye now.